Hi there. Welcome to my video where we're going to go over the solutions to the practice quiz for the trigonometry unit. So we're going to go through 3 different pages with 6 trig problems and then some quadratics at the end. And page 1 is all about SOHCAHTOA trigonometry. And remember, you can only use SOHCAHTOA, sine, cosine, and tangent, if you have a right triangle. And all 3 of these are right triangles. So starting with this one, and with all of these, we have to start by writing an equation using one of the 3 trig ratios, sine, cosine, or tangent. And let's start with number 1 here. With relation to the 54-degree angle, the unknown side is adjacent to that angle. It's next to it. And then this side here is actually the hypotenuse of the triangle because it's across from the right angle. So in this case, we're going to use cosine because cosine uses adjacent over hypotenuse. And so when we write the equation, we would say the cosine, and it's always an angle that gets plugged in. So the cosine of 54 degrees is equal to adjacent over hypotenuse, so x over 16. In a problem like this, where the unknown is in the numerator, it's being divided by 16. So we should undo this x divided by 16 with times 16, and we do this when we do 16 times the cosine of 54. And that's all we have to do to get this answer. And so let's just jump over to our calculator here. I'm in degree mode, so I'm going to do 16 times the cosine of 54 degrees, and I got 9.40. So I'll just be real careful and make sure I round to 2 decimal places, so the answer to this first one is 9.40. All right, number 2. Same deal, we got to figure out which trig ratio are we using. So with relation to this 25-degree angle, looks like this 35 is opposite, and this side here, well, it's not the hypotenuse, so that's the adjacent side. So in this case, we're going to use tangent, because tangent is opposite over adjacent. So we'll start by writing our equation. The tangent of 25 degrees, the angle is always the input to the trig function, and then that equals opposite over adjacent. And I've shown you this shortcut a few times. I did so in class on Monday and Tuesday. If the unknown is in the denominator, you can just take this numerator, this 35, and it can hop over to the other side. That is a shortcut, and I've explained where it comes from several times. But what we're really, to solve for x, it's just going to be 35 divided by the tangent of 25 degrees. Because the unknown's in the denominator. And I'm just going to use my calculator to figure out what that is. So I'm supposed to do 35 divided by the tangent of 25 degrees. And so we're getting 75.06 for that one. 75.06 was our solution. And then finally, for the third problem on this page, we have to find, instead of a missing side, now we're finding a missing angle, and that angle is this one here. And so when we're thinking about which trig ratio we can use, let's see here. This side is the opposite side, and then this side's across from the right angle, which would make that side the hypotenuse. And so, yeah, it is sine in this case. It's the opposite over hypotenuse. And so we would say the sine of the angle. Now, in this case, the angle is unknown. So it's just the sine of x equals 21.1 over 57.1, like that. And in order to get that x by itself, we just do the inverse sine. Remember, this is the function that undoes the sine function. These two things undo each other, and so we have to do that same thing to the other side. So it turns out that this angle is equal to the inverse sine of 21.1 over 57.1, and this is an acute angle also, so I'm just going to trust my calculator. So let's go see what the inverse sine of that is. So let's see here. I'm going to clear this, and I hit inverse sine 21.1 divided by 57.1. I believe that those are the numbers. And so remember, with angles, sorry about that. With angles, you can round them to the nearest degree, the nearest whole number. So I'm going to say that that's a 22-degree angle. And so that's our solution for the third one. So those are the solutions to the SOHCAHTOA page. And use that as you continue on the quiz. But now let's look at the law of sines and the law of cosines. So these two problems involve the law of sines, which I didn't type out before I got here, but remember, the law of sines just says the sine of, in any triangle, the sine of an angle divided by the opposite side is equal to the sine of any other angle divided by its opposite side. So considering number 1 here, we have to find a side. Okay, so we start by writing the sine of an angle, so 24 degrees, divided by the side that's opposite of that, well, that's 23, is equal to the sine of another angle, so in this case it's 60 degrees, divided by the side that's opposite of that one, which is the unknown side, x. And I believe that I've told you many times that with equivalent fractions, especially complicated ones like this, the easiest thing to do is to set the cross products equal to each other. So the denominator of one side multiplied by the numerator of another, 23 times the sine of 60 degrees, will be equal to the other cross product, the other denominator multiplied by the other numerator, so x times the sine of 24 degrees. And then to finish this problem off, we have to get that x by itself. So let's just divide by the sine of 24 degrees. Remember, all of these, the sine of anything is just a number, and you can divide by a number. And so it turns out x is equal to 23 times the sine of 60, all divided by the sine of 24. And so I just need to use a calculator to approximate that. So let's do that. It was 23 times the sine of 60. I'll just hit enter. And then I need to divide that by the sine of 24 degrees. And so we get this number 48.97. It's really close to 49, but we'll just say 48.97. And so I'm going to note that here, 48.97, and that's my answer. Now, the second problem here with the law of sines, this one involves finding a missing angle. And note that this angle is an obtuse angle. But we still set it up the same way. So we would say the sine of an angle, so in this case 42 degrees, divided by 735, that's the side that's opposite, is equal to the sine of the angle I'm looking for divided by its opposite side, which is 920. Now you could do the cross product. However, since the unknown is in the numerator, it's actually probably easier to just multiply by this denominator to undo the division, just like I did earlier in this video. So I'm going to multiply both sides by 920. And so what I have is that the sine of the angle that I'm looking for is equal to 920 times the sine of 42, and all divided by 735. So then that means that the angle that I'm looking for, it will be the inverse sine of that entire expression, because inverse sine is how you get x by itself. So I need to do 920 times the sine of 42 and divide that by 735. So let's do that. 920 times the sine of 42, and I'm going to divide that by 735. Notice that I closed the parentheses there. So I get this 0.8376 or so, and then I just need to take the inverse sine of that whole thing. So now I click inverse sine, and I'll just punch in the most recent answer. So I got 57 degrees, right? And so my calculator tells me the inverse sine of this thing is 57 degrees, but obviously I know that that's not actually 57 degrees. So what I have to do instead is do 180 minus 57, because it's an obtuse angle, and what I get is 123 degrees. That's the actual answer. Okay, that one's tricky, but be very careful when you do this. You can expect a similar kind of problem on the quiz. The last problem on this page is, I guess I have it over here, the law of cosines, which, remember, this is extra credit. The law of cosines says that a side squared, c squared, is equal to a squared plus b squared minus 2 times a times b times the cosine of c, where these side c and angle c are opposite each other. So when we start plugging things in, remember, the unknown usually goes in place of c squared. And then a and b are the other two sides. So 34.4 squared plus 45.5 squared minus 2 times 34.4 times 45.5 times the, I'm running out of room, cosine of 108 degrees, right? That angle C is opposite of the side called C. So now I'm just going to use my calculator to do all of this. So 34.4 and 45.5. I'm just going to try to remember those numbers. 34.4 squared plus 45.5 squared minus 2 times 34.4 times 45.5 times the cosine of 108 degrees. Oops, I missed the 0. I'm going to have to enter the whole thing. There we go. All right. Oh, and I missed a decimal here. Can I? Oh, I can't just. That's terrible. 34.4 minus 2 times. Oh, darn it. Okay, I missed it again. Crud. I'm sorry, everybody. This is annoying. You got to watch what you're doing. And then I'm supposed to do minus, 2 times 34.4 times 45.5 times the cosine of 108. Did I get it right? I think I got it right. Okay, good. So I get this number 4,221-ish, but 4,220.95, but I have to take the square root of that number to actually find x, because it's x squared. And so the last thing we need to do on our calculator here is take the square root of that answer. And so we get almost exactly 65. 64.97 was the answer on this one. 64.97. So, phew, we did it. All right. So I'm running long here on this video, but we still do have to go through the quadratics, and these won't take as long. So hang in there. All right, so the first problem on the quadratics page is we just have to identify the vertex and then graph the parabola. Remember that you can identify the vertex, the x-coordinate is here, and the y-coordinate is here. So the vertex of this one is positive 5, negative 9. So I'll go to positive 5, negative 9, and then I just need to plot a few more points. So if I go over 1, I should go up 1, because 1 times 1 is 1. But if I go over 2, I should go up 4, because 2 times 2 is 4. And if I go over 3, I should go up 9, because 3 times 3 is 9, and I'll go in the other direction. And so this is about what I would look for on your test. To identify the vertex, and then you can just plot the points. You don't need to draw the parabola. Number 2 here, it says first we have to complete the square. And so I'll do that work over here, because we need to identify the vertex by completing the square. So remember, we're going to write the first 2 terms inside parentheses, leave a blank, and then write the third term out here. And then the number that gets added inside the parentheses right here is half of the b term squared. So 6 divided by 2, and then square that number. Well, that's 3 squared, which is 9. So we should add 9 inside the function and then subtract 9 outside the function. Now that we've made a perfect square out of this, we can factor it down. So this factors to x plus 3 squared, because 3 plus 3 is 6, and 3 times 3 is 9. That means that f of x will factor down to x plus 3 squared, and then I have to also combine these terms. 5 take away 9 is negative 4. And then that means the vertex is at negative 3, negative 4, and then we can repeat that process of graphing. So let's do that real fast. Negative 3, negative 4. All right, and we go over 1 and up 1, but if we go over 2, we go up 4. And if we go over 3, we go up 9, because 3 times 3 is 9, and so on. And then the last problem, the very last one, you don't even have to graph. It says, what is this in factored form? So factored form, to remind you, is where we have to figure out how to rewrite it as 2 different factors, like so. All right, and we need numbers that multiply to equal negative 14, but also add to equal negative 5 here. And so if you think about it for a second, 14 is 7 times 2, but if I make the 7 negative, that equals negative 14, and negative 7 plus 5 equals negative 2. So I believe that that's what we, plus 5, plus, sorry, my brain. Okay, let's try it one more time. Negative 7 plus 2 equals negative 5, which is what we want here. So it is x minus 7 times x plus 2. That's what we would put for our function here. H of x is x minus 7 times x plus 2. And that tells us that the zeros are at x equals positive 7, because 7 minus 7 is 0. And also at x equals negative 2, because negative 2 plus 2 is 0. There, we did it. That's the whole thing. I hope it's helpful, and good luck on the quiz, and I'll see you next Monday and Tuesday.